Hello and welcome to today's lecture. This is lecture number 46 of our course on blockchain and its applications. Today we are going to start a new topic, which is what is called blockchain interoperability, and this is the first lecture on this particular topic. It is important to understand that although we have talked about a lot of different blockchains, it is important to also at the same time see how we can make them work with each other. So, that is what is going to be covered in this topic, especially in these 3 lectures that we have on it. And the basic concepts that we will cover today are about what is meant by asset and what is data that is to be transferred across blockchains for different types of blockchain. Then transfer of assets in permissionless blockchains, cross chain transfer and exchange of assets. So, what they mean, what is meant by cross chain transfer, what is meant by exchange of assets and so on, and then we will see how this can be done as a first step using what are called trusted third parties and what are their difficulties. So, we will highlight those difficulties. So, these are some of the concepts that we will cover. Today's keywords include interoperability, of course, asset transfer, cross chain transfer, trusted third party and the term asset exchange. So, these are the different particular keywords that are of importance for today's lecture. Let us first introduce this concept of interoperability. First of all, as we all know by this time that there are 2 types of blockchains, permissionless and permissioned blockchains. And examples of permissionless blockchains, as you know, are like Bitcoin, Ethereum and so on. And then permission blockchains are like say Hyperledger and Corda and so on. Now, in case of different blockchains, let us consider that there is a Bitcoin blockchain, there is an Ethereum blockchain. And then we may want in some situations, as we will see in detail, that something needs to be transferred from blockchain network to the Ethereum network. Typical example would be to transfer asset. Now, this asset means what? Asset means, say I hold on to certain number of bitcoins and then I want to transfer say 1 bitcoin and I want to transfer to somebody who is in the Ethereum network and would like to receive it in the Ethereum network in the form of its cryptocurrency Ether. So, you see that now I have this asset which I want to transfer. This 1 bitcoin is the asset that has to be transferred to the Ethereum blockchain, where the recipient would now get it in corresponding number of ethers. So, the asset for that recipient will also be going up, for me the asset will be reduced. So, this is how the asset will get transferred from one blockchain to another. So, that is what we mean by interoperability, how these 2 blockchains can work together by exchanging certain things. In case of permissionless blockchains, it is about transferring of such assets, and this is typically, as I have given this example, is about cryptocurrency driven such transfer of assets. As you can understand that this Bitcoin network on its own works really fine, the Ethereum network on its own works really fine, but then how can we make them interoperate? So, that is the topic of our discussion in today's lecture and the next couple of lectures. If we talk about permission blockchain, suppose there are 2 Hyperledger blockchains, both are permission blockchains, and then we want to transfer something there. And as you understand that for permission blockchains, typically they are not cryptocurrency driven. They actually, if they want to interoperate, then they will have to transfer certain data, and this data as it is transferred, you might wonder what is the big deal about transferring the data. That data can always be transferred, but it has to be ensured that the data that is transferred from a source permissioned blockchain network to a destination permission blockchain network, it should be proven that the data that is going from one network to the next, then it is driven by consensus, that it is actually the consensus view of the data in the source blockchain which is now going to the destination blockchain. It is not that some data is there which has not yet been not yet achieved its consensus in the source network is going to the destination network. So, that is what we will see in the context of permission blockchains, that it is consensus driven. And first you will look at say public blockchains. So, our initial discussion will about interoperability in public blockchains. So, they are, as such, as I mentioned, they are like isolated silos, like completely separate networks, and they enable, of course, secure and trustless currency transactions between parties, but within that network. There are currently many such, like over 2000 different cryptocurrencies that are in operation, and each of them is working in a separate blockchain network, and they have different protocols and standards, as we have seen from time to time that Bitcoin works in a certain way, and then if you have another cryptocurrency network, it can work in a different way, and then Ethereum works in a different way. So, they have different protocols and standards. So, it is not so easy to make them work, but that is the whole point about interoperability. As we know, for any other domains also, when you have different types of computer networks, in order to do interoperability or in order to allow or facilitate interoperability, you have to come up with certain ways of defining how this translation of standards and protocols can be done. Similarly, here also we have to consider how one can do some quote unquote translation of such protocols from one blockchain network to another blockchain network. So, for the timing, we know that they continue to operate in complete isolation from one another, and we have to ensure that it is still that without affecting their own autonomy. We cannot tell, Bitcoin cannot say, hey Ethereum, you change your protocol to suit my protocol if you want to interoperate, and similarly Ethereum also cannot tell or dictate this Bitcoin blockchain to change its standards in order to make it fit with the Ethereum standards. So, they will retain their autonomy, but still they should be able to interoperate. So, let us see what we mean by this cross-chain asset transfer. Once again, remember that we are talking about now interoperability in the context of permissionless blockchains, and we have this example of Bitcoin network on the left and then Ethereum network on the right, and say Alice is there in Bitcoin network, and also she is there in Ethereum network, and she owns certain number of Bitcoins in the Bitcoin network and wants to transfer her asset of 1 Bitcoin to herself, and that is her existence or her account in the Ethereum network. And say in our discussion, let us consider that 1 Bitcoin is equivalent to 33 ethers. So, what she wants is that her total number of Bitcoins will be reduced by 1 in the Bitcoin network, and her total number of ethers in the Ethereum network should go up by 33 ethers. And it is not always necessary that it is Alice who is on both sides. It could be Alice wants to transfer 1 Bitcoin and she wants to transfer it to Bob, who is there in the Ethereum network, and Bob should receive these 33 ethers. So, as we see that it could be the same account holder in both. Of course, physically they are the same, but they are different accounts, of course, in the Bitcoin network and in the Ethereum network, but this also could be different. So, now let us take a look at how this can possibly done. So, what can be done is that this Bitcoin, first of all, is to be transferred somewhere here, which will be receiving this 1 Bitcoin from Alice and then convert it into 33 ethers to be sent to Bob in the other network. So, that is to be done by some entity, right. So, what it is important is that it can be done by using what we call as a third party. So, third party means it is not Alice, not Bob, but whom they would trust, and then what would happen is that Alice would transfer this 1 Bitcoin to that third party, and that third party would be converting that 1 Bitcoin into 33 ethers and then pay it to Bob. Okay. So, you see that this is the most straightforward and the first step, the easiest way of doing things is that for this cross chain asset transfer, you first bring in a third party. Let me give you an analogy that say I want to pay conference registration fee for an international conference held somewhere in say Europe, and then it has got a registration fee of say 200 euros. So, what I have to do is that I do not have an account of in euros. So, what I have to do is that I have to go to my bank where I have account in Indian rupees. So, what I have to tell them is that you see that I have to transfer it to this particular address, which is that account number of that bank in Europe of the conference. that 200 euros are to be transferred, and they might say, oh, that means that you have to pay say with the current exchange rate, which is like 1 BTC equal to 33 ethers, it could be 1 euro is say equal to 80 Indian rupees. So, you have to pay this 16,000 Indian rupees and then some additional fees for us doing the transfer. So, that is our charge, and then it can be done. So, then it means what, that I will write a check for the bank for the 16,000 plus something, say 17,000 Indian rupees. Bank first gets that 17,000 rupees from my account, which is in Indian rupees. Now, bank will convert those, out of those 17,000, that 16,000 Indian rupees will be converted into 200 euros, and then those 200 euros will be transferred to the account of that conference held in euro in some bank in Europe. So, you see that that is where this notion of third party comes, and this third party in this example is the bank who is going to do the conversion and make the payment. So, just as there are these account numbers and so on, we have this Ethereum address and the Bitcoin address of Bob and Alice. So, this is how one can do. So, it is like cross bank, cross currency transfer of asset, which all of us might be or most of us would be familiar with. So, similar concept is being used or can be used for doing cross chain asset transfer in the context of blockchains. But let us see that if that is the case, whether there are certain issues. So, as we mentioned that we have this trusted third party, but now the difference between the previous diagram and this one, if you notice that here in an abstract sense we had drawn that rectangular box where we showed that it was receiving 1 Bitcoin from Alice and it was transferring 33 ethers to Bob. And then now if you see that actually if you want to make it happen, this trusted third party should be one who should have an account in the Bitcoin network to be able to receive that 1 Bitcoin from Alice, because you see that Alice cannot transfer 1 Bitcoin from Bitcoin network to a bank. So, this trusted third party also, as clearly noted here, that it indeed is a node with an account basically in the Bitcoin network, and on the other side again that it also has this account in the Ethereum network. So, because this trusted third party or TTP as we call it, TTP is holding an account in the Bitcoin network. So, Alice can transfer 1 Bitcoin to that TTP, and how to do that we have seen it, like it would be a standard Bitcoin transaction which has to be originated by Alice, and then if you remember I am linking these steps with our previous learning. With a script pub key, Alice will be actually creating the transaction, and then trusted third party will be able to later use it, be able to use it in the Bitcoin network only by using script sig and so on. Okay. But if the trusted third party receives that 1 BTC from Alice by verifying the transaction, so the TTP knows that indeed it can later on use this 1 Bitcoin again in the Bitcoin network for some other purpose. Now, once it is sure that it is going to receive that 1 Bitcoin from Alice in the Bitcoin network, now what it can do is that, of course, this particular node on the Bitcoin network is not directly doing anything with the node in the Ethereum network, but this trusted third party, what it can do is that now that it has got that 1 Bitcoin from Alice, now from its this balance of ethers in the Ethereum network would be able to transfer 33 ethers to Bob, creating similar transactions, and which is to be actually verified and included in Ethereum blocks, and that is how it can be transferred to Bob. Similarly, you see that it can later on get this request for transferring of say maybe 66 ethers from Bob to Alice or from Carol to Tom and so on. So, at that time what it will do is that whatever its number of ethers went down for this transfer, again when it is transferring back, its number of ethers would be going up, and then it will be sending these bitcoins in the Bitcoin network, and its balance in the Bitcoin network will be going down. So, it will do all this. So, that is what its role is, and that is the reason if you see that of course, it is to be ensured that this trusted third party has to own greater than or equal to 33 ethers when this particular transfer is taking place. So, that is quite obvious, otherwise this transfer cannot be done by this trusted third party in the Ethereum network. So, that is pretty simple. Now, this TTP based asset transfer, there are hundreds of centralized cryptocurrency exchanges. So, these are like the exchanges which are going to do these types of transfers, the asset transfers across these permissionless blockchains. So, they are typically centralized, and the users would transfer ownership of their funds to the sole control of the exchange administrator, just as in the example of bank, as I said, that the banks will first deduct those 17,000 rupees from my account. So, what it means that I have actually, like a user, I have transferred the ownership of those 17,000 rupees to the bank. So, here in the context of blockchain, that the users are actually transferring ownerships of their funds to the sole control of the exchange, right. Now, it is generally could be fast, that once this is done, the transfer to the destination network could be in a fraction of a second. Of course, it is dependent on how efficiently this particular exchange is running, and also there is a problem, or there is this chance of something that can go wrong, as we will see in the very next slide, that once the fund has been transferred to this particular exchange, now you are so called at the mercy of the exchange to do the needful in completing the transfer on the other side. So, what is the issue with this TTP based asset transfer? There is lack of security. There have been many cases of theft from the centralized exchanges, because the exchanges are going to have lot of this balance in multiple such different cryptocurrency networks, and then would be good targets or lucrative targets of the attackers, that they would try to attack these exchanges, and then that can lead to theft from these exchanges. And there are some examples that from some exchange something was lost, because if in between my fund, say Alice's fund in this example that we talked about, was transferred from her account in the Bitcoin network to the TTP's account, and then before TTP could transfer those 33 ethers in the destination account, which could be Alice or it could be Bob or somebody else, then before that happens, if for some reason the exchange shuts down, then you see that Alice's money would be lost, and there may not be any control at all. Okay. So, there are these examples that some of the exchanges had shut down, and then that led to a lot of loss of bitcoins for different such account holders who were using those exchanges for cross chain asset transfers. So, these are some of the different risks that are there with TTP based asset transfer. Next, what we talk about is that this exchange of assets. So, here what we have is, if you look at this, this is very similar to the notion of asset transfer, and it could actually be used for asset transfer. It is what we have denoted as asset exchange. So, what we have here is that the difference with the previous figure is this, that here Alice and Bob both have accounts in the Bitcoin network as well as in the Ethereum network. So, in the Bitcoin network, Alice would be transferring this 1 Bitcoin to Bob, and in the Ethereum network, Bob will be transferring these 33 ethers to Alice. So, you can actually treat as if this Bob is the trusted third party. So, in that case, you see that this particular diagram would look indeed similar to what we have here, but instead of using such a trusted third party, which is like a centralized cryptocurrency exchange, what we are saying here is that we are using, say, some other such Bitcoin account holders like other individuals. So, today Alice could use Bob for doing this transfer. So, Alice wants to transfer 1 Bitcoin to herself in the Ethereum network. So, she would expect that in her Ethereum network she would get those 33 ethers, and she will have less one Bitcoin less in the Bitcoin network. Now, the question is that today it could be done through Bob, and tomorrow Alice could do it through Carol, and so on. So, we do not have any particular centralized exchange as such, who is only going to do these types of asset exchanges. So, what Alice will do, it is similar to the TTP, but then Alice will have to ensure that Alice transfers this 1 Bitcoin to Bob, and then Bob also transfers 33 ethers to Alice, because then the whole thing is getting done in a decentralized manner. We are not depending on a centralized such exchange. But what is important also here is that here now we are talking about individuals. So, because Alice is going to transfer 1 Bitcoin to Bob, and Bob as an individual might just take that 1 Bitcoin and then not complete the second part of the transfer, which is sending those 33 ethers from Bob's account to Alice's account in the Ethereum network. So, what is to be ensured that we cannot have a protocol where Alice will send 1 Bitcoin to Bob and let Bob decide when he will send that 33 ethers to Alice in the Ethereum network. So, what is of interest to us is that how this transfer in the both the networks, one is from Alice to Bob in the Bitcoin network as designated here as the network number 1, and from Bob to Alice, which is the second step, which is the second part of the entire transaction 2, must be atomic. So, you see that it has got this term atomicity. So, if you have studied database course, you know that they are the properties of transactions are that they should be atomic. So, if there are multiple operations that make up a transaction, then in the if the transaction indeed satisfies the property of atomicity, it means that either all of those operations will be complete or none of them. So, if there are, say, we read about this particular example of transferring 100 rupees from account A to account B in the context of atomicity property of database transactions. So, that means that A balance will be reduced by 100. So, A equal to A minus 100 and then B equal to B plus 100, and these operations are to be done in an atomic manner. So, so that either 100 rupees actually will be transferred from A to B, or if there is some difficulty in between, in that case nothing will be transferred. It should not be ending up in a situation where A's account was reduced by 100, but B's account was not increased by 100, or A's account was not for some reason reduced by 100, but B's account got increased by 100. So, that is what we mean by atomicity, and exactly in the same way in the context of such asset exchange across multiple such Bitcoin or blockchain networks like Bitcoin and Ethereum in this particular example, what we would like is that this transfer of 1 Bitcoin from Alice to Bob and transfer of 33 ethers from Bob to Alice, they must be done in an atomic manner. So, you see that this is of course more challenging than the database example that I gave. It is because that this is a completely an independent network and this is completely an independent network. So, it is to be ensured that whatever protocol we come up with, that would work, so that even if these two are two completely independent networks, there should be some guarantee that this transfer will take place from Alice to Bob, and the transfer that will take place from Bob to Alice, they are both dependent on a common condition, and when that condition is met, then the first transfer also will take place and the second transfer also will take place. As a result, what will happen is that if for some reason the first transfer does not take place, the second transfer also will not take place, and it will also be guaranteed that if that the two parties decide even in the middle of the process of transferring or exchanging of this asset from Bitcoin network to Ethereum network, if any of the parties decide to back out for some reason, then they will be actually not be worse off, that they will be retaining their own balances in the respective cryptocurrency, their accounts. So, that is what is to be ensured by the protocols, which we will discuss in detail in our next lecture, but here also we have to consider what are the challenges, that without the presence of any escrow, that means that no one is actually holding on to these funds while the transfer is taking place. Okay. So, that is what we mean by escrow. The funds are in the control of the sender and receiver parties. So, as I mentioned that once if Alice transfers 1 Bitcoin to Bob, now this fund is in the control of Bob, which is the receiver party, which is now received it and then has to ensure that Bob also transfer it to Alice in the Ethereum network. So, as mentioned that because it is in the control of these individuals, this is not like a more like a trusted exchange, which generally is expected to behave in a standard manner, but because it is about these individuals. So, one party might abort the exchange after receiving funds. So, it is very important that we ensure that these types of situations are really considered important when we design the protocols for such asset exchange across multiple such permissionless blockchain networks. And synchronization problem between the two networks as well as sender and receiver, that of course, that there is no central clock or anything like that. So, we have to ensure that there is some notion of synchronization, because it is also sometimes difficult in agreement on exchange rates. For example, that I gave this example of 1 Bitcoin equal to 33 ethers, but these rates vary very frequently, as is mentioned, every second or fraction of a second also it can vary. So, you can actually check the rates. So, when you are going to convert from say Bitcoin to Ethereum, so if when Alice is willing to do the transfer, say 1 Bitcoin is equal to 33 ethers, and then when Bob is actually completing the transfer, maybe the rate has varied. So, in the process of doing the transfer, if it takes a substantial amount of time, then in between, because of the exchange rate fluctuations, then the parties might say, no, it was not a great idea to do the transfer and I am not happy with the transfer. So, these types of difficulties and then these issues can come up. So, one has to ensure that those types of difficulties are indeed addressed when we talk about the protocols for asset exchange. So, it is a very interesting problem, but it also is a difficult problem that needs to be solved by attending to all such possible issues that can come up, that not always everything will go as planned, and sometimes there would be some sort of difficulties which are to be addressed. Again, it is very similar to the database transactions concepts, where we know that there could be situations where there could be a system crash and we have to recover from those crashes and then ensure that still the properties of the transactions like atomicity etc. are maintained. So, to conclude today's lecture, we have introduced the basic concepts of interoperability, which is very important and it is a requirement, and especially that otherwise all these blockchains have been developed in such a way that they work almost independently with no connections, and there is not a standard set of protocols that actually would determine that how steps are done in one network or how steps are done in the other network, and that is of course is not the intention. They should be able to develop on their own, but then we see that there is this need for asset transfer in permissionless blockchains. We have seen this example in which the asset transfer can actually be done with the help of trusted third parties, but also we have seen that with trusted third parties there could be certain difficulties, like these exchanges they could have some problems, or if they shut down and they are holding on to the money or fund of certain individuals, and the moment they shut down, so those will be gone. So, we would like to avoid that, and then we talked about this asset exchange, but after having defined the problem of asset exchange, we also in the last slide we also highlighted that what are its challenges, because it is not something that is so easy to design. So, it is important to give due consideration to all such challenges while deciding or determining a particular such protocol for asset exchange across different such blockchain networks. And also it would be good to see that the protocols that are designed, they would work not only for two specific networks like Bitcoin and Ethereum, but they should be more generic in nature, so that same types of algorithms with network specific modifications they should generally work. So, we will see in the next lecture one such particular algorithm that can be used for asset exchange across multiple parties on multiple networks. So, to give you some ideas again about the references. So, there are indeed not yet really textbooks that talk about the recent advances in interoperability across multiple such networks. You can look for some reference books, but it is best that you go through the different web resources that we mention from time to time, and there were a few those are listed in today's lecture. When we talk about particular protocol in our next lecture, you will see that we will refer to the papers which are published in good conferences, and they are seminal papers and which are cited very often. So, it will be good that you go through those sites and then complete the discussions. So, with that we come to the end of today's lecture. Thank you very much for your attention.